Well, welcome to our wonderful lesson here, Fundamental Theorem of Calculus, Day 1. There you go. So what's important about this one is this is really being able to use the Fundamental Theorem of Calculus using word problems, really. Whereas before we were just straight up just solving. Sorry, I'm going to adjust the camera a little bit. Where we're just straight up solving actual problems, and now we're going to be given word problems. By word problems, I mean sometimes they actually are word problems, or sometimes they're just giving us the problem with some extra words or graphs or whatever. And we're just going to use the Fundamental Theorem of Calculus to solve this stuff. Okay? So let's start with this problem right here. And we're going to first solve it without the Fundamental Theorem of Calculus, and then we will solve it with it. Okay? So if we're given the derivative, which is 3x squared plus 4x minus 5, with the initial condition of y of 2 is equal to -1, let's go ahead and find y of 3. So the method that we could do is we could just go ahead and integrate this to get our original function, find c, and then use that value to find y of 3. So I'm going to go ahead and do that for you. So when we go ahead and integrate this, we're going to get x to the third plus 2x squared minus 5x plus c. And this is my original equation by finding the antiderivative of that. Since I know that y of 2 is equal to -1, I can do -1 equals 2 cubed plus 2 times 2 squared minus 5 times 2 plus c. And I can do all of this to find my c value of, I'm just trying to cheat real quick, that way I don't have to waste too much time. Looks like it's -7. So c is equal to -7. I'm just doing arithmetic quick. That way I don't need to have a long video. Nobody wants that. So this equation really becomes y equals x cubed plus 2x squared minus 5x minus 7. Okay? Now we can find y of 3 by plugging in a 3. So plus 2 times 3 squared minus 5 times 3 minus 7, which is going to give me an answer of, again, I'm cheating a little bit. I have my notes already done. It's going to give me 23. Just going through this fast. I don't want the video to be too long. So that's one way to do it, which this problem's a polynomial. It's really not that bad. You can do it that way. No issues with that. Or you can use the Fundamental Theorem of Calculus. Okay? So since we do know this, all right, and this is going to be the way that I like using it, even though it might not necessarily be easier for a polynomial problem, it's going to be much easier for us moving down the road. And especially if you have a calculator in your hands, you're going to want to do it method number 2 here with the Fundamental Theorem of Calculus. Okay? So to do this one, what we're going to do is we're going to head and integrate, same problem, different method. We're going to integrate from 2 to 3 of this 3x squared plus 4x minus 5 dx, which is going to give me x cubed plus 2x squared minus 5x, and we're going to end up evaluating that from 3 to 2. But what's nice to know about this is that this is equal to f of 3 minus f of 2. In this case, we'll use y's, or f's instead of y's, doesn't really matter. So I do not know f of 3, but I do know f of 2. What is f of 2? It's -1. Okay, so that's going on the right side. And on the left side, I'm just going to go ahead and just plug this all in. So I'm going to get 3 cubed plus 2 times 3 squared minus 5 times 3 minus 2 cubed plus 2 times 2 squared minus 5 times 2. And then we can just solve the left side, solve the right side, and then we can go ahead and get a lovely answer here. So this is going to give me, sorry, I am trying to cheat a little bit. This is going to give me 24 equals f of 3 minus, plus 1. So f of 3 is going to equal 23. All right, so same thing. I just used F notation here. Not a big deal. Get the same answer here for those. All right, I went through that pretty gosh darn fast because I was ignoring a lot of the algebra. Reason is because a lot of times this is a calculator active question. So I'm going to hit up my handy dandy calculator and go ahead and do this problem right here. Here we go. So I'm given the derivative, and I need to solve for this. So I'm going to do this. I'm going to integrate from 1 to 2, because I have 1 looking for 2 of sine of x squared dx, and that's going to give me f of 2 minus f of 1. Now, with what I know right now, I cannot find the integral of that, but that's okay, because what can? Our handy dandy calculator. So if you go to alpha window, which is my F2, you have that integration option down here at 4, and now you can actually integrate from 1 to 2 of the sine of x is being squared dx. Okay, also make sure your mode, I need to check my mode because I haven't used this before, make sure you're in radian mode, because we always do calculus in radian mode unless we have a word problem that specifically asked for degree, but calculus spits out radians anyway. So we hit enter. This is going to give me this 0.4945, and there's a lot more numbers, and that's going to equal my f of 2. I do not know f of 2, but I do know f of 1 is -5. So to find this now, I'm going to get 0.4, make sure it's on the screen, 945. If you notice, I hit ... which just means that there's more numbers. I don't feel like writing them down. That's going to be f of 2 plus 5. Okay. So what I'm going to do now is subtract 5 from both sides. And so f of 2 is going to equal this 0.4945 ... minus 5. So my final answer of that is going to be, well, let me subtract 5 from that, negative 4.5055. Again, you just need 3 decimal places. I just put 4 just for the sake of your notes so you can see them. But yeah, that's it. So what if you're given f of 2 and then you're asked to find f of 1? Well, nothing would really change except your number would go there and you're trying to look for that. So nothing really changes. So setup is the same. But plug in for f of 2 and solve for f of 1. So if you're solving for f of 1, you're just going to need to do an extra step, and that's really it because it's minus f of 1. Okay, so that really is, in a nutshell, the fundamental theorem of calculus, using it to our advantage, especially on these problems where we're given a calculator, and you'll see it in a moment when we're given a graph or a table. It's also pretty convenient to do it this way as well. Okay. So the graph of f prime, which is right here, consists of 2 line segments and semicircle. That's to help me use my geometry skills on the right. Given that, so this is it, all of it right here. Let's go ahead and find f of 0. All right. So to find f of 0, are we given enough information here? I feel like these notes are missing something. F of -2. So given that, I think it's saying this is f of -2. I'm just making sure f of -2 is equal to 0. We're going to find this information. Sorry, I think the notes are missing that right there. So given that f of -2 is equal to 0, we're going to go ahead and find this stuff out right here. Okay? So to find f of 0, since I know -2 and 0, again, this is part of the question that just wasn't written in there. Find f of 0. Let's go ahead and set up my handy dandy equation here. So I'm going to integrate from -2 to 0 of f prime. And that's going to equal f of 0 minus f of -2. So let's find the area from -2 to 0. So this is going to give me an area of, right here, the triangle, 1/2 base times height. It's going to give me 4. So this is going to say that 4 is equal to f of 0 minus 0, again, because I was given f of -2, which is 0. So f of 0 is equal to 4. Beautiful. Now let's go ahead and do letter B. So f of 2. Now I know two different values. I know 0 and I know -2. So it doesn't matter what you use. So I'm going to go ahead and just go from 0 to 2 since I already know 0. And it's less geometry for me to do, less counting. So this is going to be f of 2 minus f of 0. So, well, from 0 here to 2, that is 4. So this is 4 equals f of 2, which I do not know, minus 4. So if I solve for f of 2 is going to equal 8. Okay? F of 6. Again, you can integrate from whatever you want. For the sake of geometry here, I'm going to actually just integrate from here to here. So I'm going to do from 2 to 6. And that's going to equal f of 6 minus f of 2. So this area right here is, oh my garage, it's a semicircle. So it's going to be 1/2 r squared times pi. R is going to be the radius. Since it's a semicircle, radius is 2. So this is going to be 2 pi. So it's down below. So it's going to be a negative. I'll write this in red because it's negative. That's not red. So this is going to be negative 2 pi. So negative 2 pi equals f of 6 minus f of 2, which is 8. So f of 6, after doing some math here, is going to be 8 minus 2 pi. And that's how you find those out using your fundamental theorem of calculus. All right, here is another problem. It's nice as they tell us the area for all of these, so totally awesome. Hey, this problem's actually written out nicely. It actually tells us what f of 3 is. So we're going to go ahead and find f of 0 using this graph right here. And it tells us that f of 3 is equal to 5. Perfect. So to find f of 0, let me integrate from 0 to 3. And I can do that because I know that area. So 0 to 3 of f prime of x dx is equal to f of 3 minus f of 0. Well, this said that the area is 4, so it's 4 equals f of 3 minus f of 0. So 4 equals f of 3 is 5 minus f of 0. So if I were to solve for this, if I flip the f of 0 over there on the other side, so I'm going to get f of 0 equals 5 minus 4, which is going to give me a 1. So this is equal to 1. Perfect. For f of 7, I'm going to do the same. I'll use different colors so it doesn't look as squished. So I'm going to integrate from 3 to 7. Okay. Now from 3 to 7, it says my area here is 9, but it's below, so it's actually a negative 9. So negative 9 equals f of 7 minus f of 3, which is 5. So if I add that on over, I'm going to get an answer of negative 4 for f of 7. And then for f of 9, I can just go from 7 to 9 very easily without having to count too much. And that's going to equal f of 9 minus f of 7. So this is 2, which equals f of 9 minus f of 7 is negative 4. So that's going to give me 2 equals f of 9 plus 4. So subtract that, and you're going to get negative 2. Okay, and now I'm going to use that information here, and I'm just going to give it a quick little sketchy poo for what I do know. So I know that f of 0 is 1, f of 3 is 5, 1, 2, 3, 4, 5. F of 7 is negative 4, so 1, 2, 3, 4. And then f of 9 is negative 2. So this is my graph right here. I really don't know too much about it. Okay, so other than just these points. I do know that it is increasing until 3. and I'm decreasing until 7. So I'm just going to decrease till 7, and then I'm increasing until 9. So that's about it. If you notice, I have an inflection point here at, I don't know, it looks like 1.5. Inflection point here at 5. And then inflection point here at 8. Again, kind of hard to tell, but not too worried about the sketch of things. I just want to make sure that you understand that you can use this to plot to the original. And that's it for fundamental theorem of calculus. For using it with calculator and graphs is really the main focus, not the first problem we did, but really just trying to get you to know how to do this using graphs and calculators.